Hey chemists, we're going to go over counting atoms, and we're going to learn about another type of compound that has parentheses in it. But before we get there, you could check your answers to the previous examples right here. For KCl, you should have got 2 ions total. For C6H12O6, you should have got 24 atoms total with those different elements there. And then finally, for this last one, you should got 63 atoms total. Sometimes you got to make a little bit more difficult ones. So you could check your answers there. To end these set of notes, we're going to talk about other types of compounds, and I want to refresh something that you may have learned in math class called the distributive property, because some compounds contain more than 2 elements with a parenthesis, or like parentheses. That actually should be parentheses with the ES, if you want to put that. Counting them requires a math skill, something called the distributive property. If you remember in math class, if I have a number outside of a parentheses, you do what's called distribute that number. So if I had 3, 2x plus 5, I distribute the 3 to the 2x, and I distribute the 3 to the 5, and I have 3 times 2x is 6x, right here. 3 times 5 is 15, and I end up with 6x plus 15. If I didn't do this with x's, if I did like 5, 1 plus 5. I mean, this we know this is going to be equal to 30, but I'll show you how you can do that with distributive property. You do 5 to the 1 becomes 5. 5 to the 5 is 25. This just equals 30. Same idea. For chemistry, we're going to see something like where we have something like NO3 with a little number on the outside, and we're going to distribute that number in the same way to count atoms. So that's a little preview. So here we go, counting elements and atoms. We could calculate the total number of atoms, including the parentheses. So if I have something like this compound here that's called aluminum sulfate, this formula means aluminum is bonded to a molecule of sulfur and oxygen. And I'm going to actually draw the particle diagram so we could see where all of these numbers come from. If I represent aluminum with this dark blue circle, and I represent sulfur with a red circle, and then oxygen with a purple circle, let's draw that. We have 2 aluminums, and then there's this thing that says SO4, which we have not learned about these in detail, but this is known as a polyatomic ion. We're going to draw them. There's 1 S and 4 O's. So I could represent an S with a red circle and an O with a purple circle. 1, 2, 3, 4. Now this parentheses tells me that there are 3 of these SO4s. So I'm going to draw those in total here. 1, 2, 3, 4. 1, 2, 3, 4. These are all of the ions for this compound. There are 2 aluminums and these 3, what's known as a sulfate, and we'll just write here SO4 with a 2- charge. That's called sulfate. This is a polyatomic ion. It has 1 sulfur for 4 oxygens. If I want to count all of the atoms, and I'll count them with little dots here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 17 atoms in total to draw all of these. That would be a lot of extra work to have to draw and count all of them. There is a trick. The 3 on the outside multiplies to everything on the inside. So what this is really saying is I have Al2. There's no parentheses on the outside of that. There are 3 sulfurs, and now, because 3 times 1 is 3, and then 4 times 3, there are a total of 12 oxygens. So this becomes 2 aluminums, 3 sulfurs, 12 oxygens, 12 plus 3 plus 2, that's 17 atoms total. So to find the total number of atoms for a compound like this, you multiply whatever the subscript is on the outside by each element inside the parentheses, and so we get a total of 17. Let's do that for our examples here. The first one's done for us here. This is BaClO2 We have not learned to name this, but we'll put the name in for fun. This is barium hypochlorite. Just for fun. Hypochlorite is a ClO minus ion. There are 1 bariums, and this little 2 tells me that there are 2 of these ClOs. It's actually ClO minus. So that's 3 ions total, but we got to count the atoms, which is what's more important. That 2 multiplies on the inside, so that tells me that there's 1 barium, 2 chlorines, 2 oxygens. That's a total of 5 atoms. Let's do this NH42S. We'll put the name here for fun. This is ammonium sulfide. Now, I want to stress that you don't have to worry about naming these for any future quiz or test. You'll be given these names, but being able to count the atoms in these formulas, you will need to know how to do. So in this formula, this is NH4 in parentheses, and there's a 2 on the outside. That means that there's 2 of these NH4 businesses, and that's NH4 plus ion. And there's only 1 S on the outside here. That's a 1s2 minus ion. So in total, there's a total of 3 ions. But now we got to count the atoms. For N, this 2 distributes to the 1 N that's there. So 2 times 1, there's 2 N's. This 2 also distributes to the 4 H's that are there. 2 times 4 is 8 H's. And there's no parentheses for the S, so it's still just 1 S. 8 plus 2 plus 1, that's 11 atoms total. Let's do one more together, and then I'll leave you for the last one on your own. Aluminum, or AlNO32. We'll name this one for fun. This is aluminum nitrate. And you can see that there's no parentheses outside the aluminum. There's only 1 aluminum ion here, but there are 2 NO3 minus ions. There's a 2 outside with the parentheses. That parentheses tells me that there's 2 of these NO3s. NO3 is known as nitrate. It's a -1 charge. So in total, there are 3 ions. But now let's count the atoms, which is the most important thing of this quick lecture. I have to distribute the 2 on the inside for the NO3, but there's only 1 Al still. So there's 1 Al atom. I distribute the 2 to the 1 N. There's 2 N's. I distribute the 2 to the 3 for the O's. There's 6 O's. 6 plus 2 plus 1, that's 9 atoms total. All right, I'd like you to do this last one on your own. I'll cut the video off here. Just for fun, let's put the name of this compound. This compound has 2 polyatomic ions. This is ammonium phosphate. And again, I said this earlier, you're not going to have to worry about naming these things or recognizing these things. The most important is being able to count the atoms. I'm going to let you know that there are a total of 20 atoms. I would like you to try and find them in this compound of NH4 3PO4.